Hello friends, welcome back. Hearty welcome to you. Let's have a look at this problem. A square is constructed on the portion of the line x plus y equals to 5, which is intercepted between the axes on the side of the line away from the origin. The equations to the diagonals of the square are, we have to find out the equations to the diagonals. We have been told that a square is constructed on the portion of the line x plus y equals to 5, which is intercepted between x axis. So let's understand. Let us say, suppose x plus y equals to 5. X plus y equals to 5. That means we know that x by 5 plus y by 5 equals to 1. That means this intercept is 5, 0. And this intercept is 0, 5, and this is where the line is intercepting the coordinate axis. Now we have been told that a square is constructed on the side of the line away from the origin. That means not this side. We have constructed the square on other side. So let's try to construct the square. So if I have this length, I'll go that much, again the same length, and let's try to join this. Let us say approximately this is our square. Now we have to find out the equation to the diagonals of the square. So let's join the diagonals. That's one diagonal I have, and this is another diagonal I have. These are the two diagonals I have. Now we have to find out the equations to the diagonals of the square. So let's start with let's say that this point is O, this is A, and this is B. Now we know that AO equals to OB because AO equals to OB equals to 5. We got intercepts are equal. That means these two sides are equal. Then AOB is a isosceles right angle triangle. That means we know that this angle is equals to that angle, and both of them are equal to 45 degrees. Because in a right angle triangle, if legs are equal, then it will become an isosceles right angle triangle, and all the angles are 45 degrees. We also know that diagonal divides the side. Diagonal is the angular bisector in square. That means this angle is 45 degrees, that angle is 45 degrees. Similarly here, this angle is 45 degrees, also this angle is 45 degrees. We also know diagonals of a square bisect with each other at right angles. Therefore, what we got here, this particular quadrilateral is a square. We have a square here, and we know in square opposite sides are parallel to each other. So leveraging that, we can easily find out the equations of the diagonals. Let's look at this diagonal. Suppose this diagonal is parallel to x-axis because it's a line which is parallel to x-axis and passing through point 0, 5. We know that any line parallel to x-axis is given by y equal to k, and here k value equals to 5. So the equation of one diagonal is y equal to 5. Similarly, the other equation, diagonal equation, will be, it is a line which is parallel to y-axis and passing through point 5, 0. And that equation is given by x equals to k, but k equals to 5. So the equations of the diagonals of the square are x equals to 5, y equals to 5. Let's summarize that. We have been given that there is a straight line x plus y equals to 5, which cuts intercepts between coordinate axis at 5, 0, 0, 5. A square is constructed taking this side away from the origin. We have constructed a square because I can construct the square this side also. We want to construct it on the opposite side. Now we have to find out the equations of the diagonals. We know that x plus y equals to 5 will have equal intercepts. That means they form an isosceles. The straight line and the coordinate axis form an isosceles right angle triangle. And we also know diagonals of a square make 45 degrees because diagonals are angular bisectors. And we know in square each angle is equals to 90 degrees. Then we observe that the diagonals are parallel to the coordinate axis, passing through the points 5, 0 and 0, 5 respectively. Therefore, their equations are x equals to 5, y equals to 5.